Now we have a question number 1. That is the main problem for the EOT. And we need to understand this question. A nurse wants to administer 80 milligram of this medicine to heal an injured soccer player. Okay. We need to understand, let's say we have a player who is in the hospital and one nurse is giving a dose to the patient, to the soccer player. Okay, so the quantity is given. Quantity is how much? 80 microgram. So what is 80 microgram? I already told you. So 80 multiply 10 raised to power negative 6 gram. Okay, if she uses, and this device, okay, this is a particular name of the device that applies a current. Okay, so current, what is the value of current? I is equals to 0.14 milliampere. So 0.14 times 10 raised to power negative 3. We know now milli means 10 power negative 3 ampere. Fine. How long? So what they are looking for? They are looking for the time. So we need to find the time. And in terms of time, we know, as we know this formula, okay, we learned earlier also, that is the QIT. So if you are looking for time, it should be charge per unit current. Fine. And current you have, and time you are looking for. So you need to looking for, now our motive is to find charge. Fine. Okay. How long does the administration of the dose take? Assume that the instrument has an application rate. What is the meaning of application rate? This is interesting. You need to focus. Application rate. Rate means speed. Rate means speed. That the machine is using 650 microgram per unit charge. Means the machine is using or sending 650 microgram of the medicine per unit charge. Fine. So what we need to understand, this is the first case, this is the second case, and we need to focus that the speed remains the same. Because if the medicine is keep on moving in the body of the player, then the speed or the rate remains same. Is it fine? So if it is same, then 80 microgram per unit x time of charge, you can understand, x time of charge, that should be equals to 650 microgram per unit 1 coulomb of charge. See, he said na per unit charge. Per unit charge means 1 coulomb of charge. So we are looking for this x. So solve this x. X should be equals to 650. And yes, before that you can cancel the units. Unit and unit is cancel. So 650 divided by 80. Fine, guys. So you just solve this part and we will get our answer in terms of charge. The value is 0.123. And what is this x? X in terms of coulomb? X in terms of coulomb. So can I say we are looking for the charge? So what is the value of charge we identify here? Q is equals to 0.123. And you can write coulomb here. See, C, time we are looking for, and current is 0.14 10 raised to power negative 3. Solve the time. T is equals to Q over I. So Q is 0.123 divided by 0.14 times 10 raised to power negative 3. So when you find out the time, guys, solve it fast. And the answer is 878 seconds. And see, generally when we are solving the time, this is the correct answer. But this is the case, as per the case of hospital. So we need to identify time in terms of minute. in minutes. To convert into minutes, so what will you do? Divide by 60. So T should be equals to 878 divided by 60, which is approximate 15 minutes. So just consider you are in the hospital, or there is someone who is in the hospital, and if he asks the nurse that how much time it will take to inject this complete medicine. So if the nurse will tell you that 878 seconds, that is quite old. So instead of that, she will tell you that it will take hardly 15 minutes. So that is much better as compared to the previous answers. So what is the current density? Okay, we are looking for J. Clear? We are looking for J. In an aluminium wire having a radius, so radius is given 1 millimeter. So guys, now, what you need to do, just solve this milli. 1 milli means 10 power negative 3 meter. Clear? Okay. Now we have the radius and carrying a current. Current is I, which is equals to 1.00 milliampere. So milli means, yes, solve it fast. 1 multiply. Milli means 10 power negative 3 ampere. Okay. Now, what is the formula for J? As I told you, J is equals to current divided by area. So we need to find area. I told you the formula. Pi R square. Pi means 3.14. And what is R? 1 multiply 10 raised to power negative 3 square. So can I say 3.14 times 10 raised to power negative 6? Fine, guys. This is your area. Okay, place the value. So we have the value of current. 1 multiply 10 raised to power negative 3 divide by 3.14 multiply 10 raised to power negative 6. So solve them fast. So what is your value? 318.318.47. Okay guys, now the unit part, you need to focus on this part. So the unit of current is ampere and unit of area is meter square. So answer is ampere per meter square. So this is your final answer. Clear guys? Okay. What is the resistance? What we are looking for? We are looking for the resistance. Okay, R. Clear? Of 100 ohm, 100 meter. Okay, length is given. L is equals to 100 meter. Guys, now what you need to think, what you need to focus, this is the major point, a standard 12 gauge wire. What is the meaning of 12 gauge wire? How to solve these type of question? Okay, just focus here. I added this table for you. 12 gauge. This is the 12 gauge. Okay, so in case of that, you will find the values in inches, in millimeter, and the area. Clear guys? Clear? So can I say for the 12 gauge wire, okay, few things what you need to focus. 12 gauge copper wire. So first thing, copper. You know, copper means material. Okay, here is your material, and what you will get, the resistivity from the table. So here you will get rho 1.72. Fine. And 12 gauge wire, 12 gauge. So what we get? We get the area, and with the unit is millimeter square. So what is the value? 3.30. Okay, delete this part, make it first, write area. Area is equals to 3.308 times, okay, millimeter square. So can I write like this value? 3.31 millimeter square. So convert this millimeter square. Okay, first I will solve for you. 1 millimeter means 10 power negative 3. Okay, 1 millimeter square means 10 raised to power negative 3 square, which is equals to 10 raised to power negative 6. Okay, so place the value here, multiply 10 power negative 6 meter square. Clear, guys? So we have, now we are looking for R, L. Okay, so what is the formula we have? R is equals to rho L divided by A. Yes or no? Okay, so just solve it and find the value. Okay, rho is given, rho is 1.72, 1.72. Okay, multiply. What is the length we have? Length is 100 meter, divide by, what is the area we have? 3.31 times 10 raised to power negative 6. Okay, so guys, solve the value first. Use your calculator. Okay, till then I'm going to solve. Okay, 0.520 ohm. Okay, and this is your resistance. Clear, guys? What are the relative magnitude? What are the relative magnitudes of the two resistance in the figure? Okay, if we see the figure number 1, we have the battery, okay, VEMF, current I, and both are connected in series. Just check why they are connected in series. Let's say current starts moving, yes or no? Okay, this is the positive plate, this is positive, here it is negative. So you will get positive, negative. You will get here positive, here you will get negative. It means they are connected in series. Fine. Okay. Now, second thing, what they are trying to show us, this is your positive terminal, this is your negative terminal. Current remains same. This is your V1, this is your V2. What they are trying to show us, delta V1 is less than delta V2. Yes or no? From here, you can easily identify who is the bigger one, delta V2. Okay. So can I say, as per Ohm's law, what is the rule? V is equals to I times R. So can I say I1 R1 is less than I2 R2? And we know I1 should be equals to I2 equals to I. Why? They are in series. They are connected in series. So can I say I R1 less than I R2? Okay, time to cancel them. Cancel. So what is left? R1 is less than R2. So just check all the options. Okay, R1, A is the right answer. Clear, guys? Okay, guys, now one by one we have the first question. Which combination of resistors has the highest equivalent resistance? Okay, we have the four different circuits and we need to solve which one has the highest value of resistance. Okay, now the first one, A part. It is very simple. We can see this. Okay, check this. From here it is going 1, 2, 3. So can I say simply all three are in parallel? All three are in parallel because from positive, okay, this will become positive, this is positive, negative, negative, and negative. Okay, solve this, huh? Case A, 1 over R equivalent is equals to 1 over R plus 1 over R plus 1 over R. So this becomes 3 over R. So what is R equivalent? Flip the numbers. R divided by 3. This is the first value. Okay. B case. Okay. Now just see. Positive, negative. From here current is dividing. 1 2, 3. All three are in parallel. Again, positive, negative, positive, negative, positive, negative. Fine. This is also the same thing. 1 over R equivalent is equals to 1 over R plus 1 over R plus 1 over R, which is equals to 3 over R. So R equivalent is equals to R divided by 3. Okay, A and B are same. Okay, now next one. This one is something good, on which you need to focus. Okay, here current is dividing this one and this one. They are in series. Yes or no? This is parallel, this is parallel, but 1 over 3 plus 2 over 3 are in series. So C case RS. So 1 over 3R plus 2 over 3R. So what will it will become? 3 over 3R. So the value becomes R. Now can we redraw the structure? So the structure will become like this. This is your R. Okay, from here this will becomes your R and this will become your R. Same like structure number 2. Okay, all three are in parallel. So you will get R equivalent same as 2, same as case B. So it will become R divided by 3. Now solve case number D. Okay, now just see. Half and half both are in series. Both are in series because the same current is flowing. Okay, here also you can see this one and this one are also in series. So can we say RS half R plus half R equals to 2 over 2R. This is the first case. RS half R plus half R half R, which is equals to 2 over 2 R, which is equals to R. And if I redraw this circuit again, if you redraw, it will become just like a B part, like this. One is here, one is here, and one is here. So again, what will be the value? All three are in parallel. And we will get R equivalent is equals to R divided by 3. Clear? So all four are same. So all four same, all four same. So your answer is E. Clear, guys? Like this, you need to know how to split and how to solve them. This is the main problem. That is the question number 1, And before explaining this question, you should know one formula, one equation for you, which is R. Okay. Now, 100-watt light bulb. So as we already studied, power is equals to 100 watt. Fine. Is connected in series. Connected in series. Okay, fine. To a source of EMF with V is equals to 100 volt. Fine. When the light bulb is lit, the temperature of its tungsten filament. Yes, now guys, what you need to focus, there is a temperature of the bulb which is 2520 degree. See, whenever there are the concept of temperature in the question, we have one general formula for that. R is equals to R naught 1 plus alpha bracket T minus T naught. I will explain this. T is equals to 2520. Okay. What is the resistance of the tungsten filament at room temperature? Guys, you need to focus. There are the two temperature and two resistance. T is given temperature, and T naught is the room temperature. Room temperature here. And there is a word called R is the resistance at that particular, let's say, if we have a temperature 2520, then we can find the R, and at room temperature, we can find R naught. So what he is looking for? what is the resistance of the tungsten filament at 20 degrees Celsius. So in the numerical, we are looking for R naught. Clear? And temperature coefficient alpha is given, alpha is equals to 0.0045. Clear, guys? Okay, time to solve. First thing what we need to know, okay, if I need to solve this whole equation, I need R also, alpha I have, time I have, T naught I have. So first step number 1, find capital R. Okay, how to find out capital R? We have the power formula. We have three formulas: VI, I square R, or V square divided by R. So I'm looking for R and R. Current is not given, voltage is given. So can I say power is equals to V square over R? Yes or no? Okay. Find R. R is equals to V square over P. Solve it. R is equals to, what is the value of V? 100 square divided by 100. Solve it. You will get 100 ohm. Clear? Okay. Now place the value in the equation. In this equation, 100 equals R naught bracket 1 plus, what is the value of alpha? 0.0045. Okay, bracket T minus, what is the T here? 2520 minus 20. Clear, guys? So you need to find the value of R naught. So just place in your calculator 100 divided by 1 plus 0.0045 and 2520, so 2500. Solve this. What is the value of R naught? Yes, guys, put in the calculator. Fast. Okay, the answer is 82 ohm. Clear? So this is the answer. First numerical. This is something which is very good. Okay, very easy, huh? Very easy peasy. Okay, just let's say I1, I2, I3, I4. We will solve this numerical. First we solve the directions. Okay, guys, I1, in or out? In. So can I say positive? Fine. Okay, check the I2. This is your I2. It is going like this. It is going out. It should be negative. Okay, what will happen with I3? I3 is going like this. This is in towards the junction, so it should be positive. I4 is going like this. It is also in. It should be positive. So can I say I1 minus I2 plus I3 plus I4 should be equals to 0. Okay, now read the question. For the junction shown in the figure, which equation correctly express the sum of the currents? Okay, number 1, I1 plus I2 plus I3 plus I4. No, I2 should be negative. Okay, I1 minus I2 plus I3. Yes, it is correct. C wrong, D wrong, E wrong. So our answer is B for boy. Clear, guys? Okay, and B for bounce back classes. Okay, now that is the main question, as per the loop rules. A 12-volt battery, okay, 12-volt battery is given with internal resistance, okay, Ri 0.2 ohm, is being charged by a battery charger. Okay, means there is an external source also that is capable of delivering a current. Okay, I is equals to 6 ampere. What is the minimum EMF? Okay, we are looking for V EMF. Okay, the battery charger must supply to be able to charge the battery. Okay, as per this diagram, there is something which you need to focus on. The direction of current. Did you observe this thing? So, which one is your charger? This one behaves like a charger, yes or no? Because the current is moving out from here. Yes, okay, it is moving like this, and it is entering and completing the circuit. Okay, now give the name to the circuit, change the color, let's say A, B, C and D. Okay guys, very easy, huh? Just make this equation and finish. Okay, start with A, let's say plus VE. Okay, keep on moving. Okay, now we are with RI. So in the same direction of current, loop and current, loop plus current, same direction. If both are in the same direction, we know it should be negative IR. So okay, negative IR1, and it is entering, okay, this one. And we know this rule, whenever in the battery the current is moving inside positive, it means negative VT should be equals to 0. Okay, now solve this, place the values. We are looking for VE minus I is 6. Okay, resistance is 0.2 minus what is VT, 12 equals to 0. VE equals to VE minus Z, it should be 6 multiply 0.2, it should be 1.2, negative 12 equals 0. Take this value that side, VE equals to 1.2 plus 12, that is equals to 13.2 volt. So guys, what is the value? The minimum value is 13.2 volt. Fine. Okay. From the EOT, consider a simple circuit consisting of source of EMF with voltage. Okay, just focus here. VEMF. Okay, the value is 150 volt. Fine. And a resistor with resistance. Okay, we have a resistor. R is equals to 100 kilo ohm. First of all, solve this. 100 kilo means 10 power 3 ohm. Okay, with resistance RV. What RV? RV is this one. Resistance of RV is equals to resistance of voltmeter. Fine. So RV is equals to 10 million ohm. What does it mean? 10 million means, or mega means 10 raised to power 6 ohm. Fine. Okay. Part A. What is the current? Okay. So now we need to solve part A. So we are looking for current I. Fine. In the circuit, before voltmeter is connected. So means for the case A, this is our circuit. Clear? So this is our circuit. So in this, it's easy, as we know V is equals to IR, I is equals to V over R. So what is V? 150 divided by what is R? 100 multiply 10 power 3. 100 multiply 10 raised to power 3. Solve it. So what we get? 1.5 times 10 raised to power negative 3 ampere. Clear guys? So this is your first. Okay, now solve the second part. What is the current? Okay, again we are looking for the current. Fine. In the circuit, when the voltmeter is connected, so it means now in your case B, what you have in case B, This is your case B. Now the full circuit you need to cover. Fine. And from the middle also. This one also. Clear? So it means I'm going to clear all these things so that it will be easy for you to understand. Now you understand, na? Okay. Now, so in this case, can I say what is the equivalent resistance? I can say this and this. Both are connected in parallel. So 1 over R equivalent is equals to 1 over R1 plus 1 over RV, voltage of the resistance. Okay, solve them. 1 over, what is R1? Okay, 100 multiply 10 power 3 plus 1 over, this is the value, 10 multiply 10 raised to power 6. Solve this. 1 over R equivalent. When you solve this, what is the value? Just guys, solve it fast. So once you solve it, you will get R equivalent is equals to 9.9 times 10 power 4. Clear? This is your R equivalent. So we are looking for I is equals to V over R. So what is the value of V? V is 150 divided by, what is the value of R? 9.9 times 10 raised to power 4. So now what we have, our answer is 1.52 multiply 10 raised to power negative 3 ampere. And guys, can you see something? From part A and from part B, when I increase the resistance, see, when we involve, so what will happen? Overall resistance reduce, current increase. See, whenever we place the voltmeter, then what will happen? Overall resistance of the system decline. Always remember, huh? Whenever we add voltmeter with the system, then what will happen? The overall resistance decline and current will increase. So this is something very, very important in case of voltmeter. Fine. Okay. Now, what is the question we have? First question, consider a capacitor, okay, consider a circuit, fine, consisting of 12 volt battery, okay. So we have V, which is equals to 12 volt, fine. A 50 ohm resistor, R is equals to 50 ohm, and capacitor is 100 microfarad capacitor, 100 microfarad, which is equals to 100 multiply 10 raised to power negative 6 farad. Okay, wired in series. Yes, that should be a RC circuit is always in series. The capacitor is initially completely discharged. What does it mean? That the value is 0. So this is the case of charging. So if this is the case of charging, what should be the formula? We know Q over Q max equals to 1 minus e raised to power negative t divided by RC. Clear? Okay, how long? So what we are looking for? We are looking for time. Okay, how long does the circuit is closed will it take to charge capacitor? 90%. Okay, in case of charging, you just need to apply the value. So Q over Q max is the 90%. 90% means 90%. Percent means 90 divided by 100, which is equals to 0.9. Okay, place the value in the formula. 0.9 equals 1 minus e raised to power negative t divided by RC. Okay, so take E this side and this value this side. So we get E raised to power negative T divided by RC equals 1 minus 0.9, which is equals to 0.1. Okay, so what we get here? E raised to power negative T divided by RC equals 0.1. Okay, taking log both side. Taking log both side. Okay, then what will happen? Log E raised to power negative T divided by RC, which is equals to log bracket 0.1. Fine. Okay, now in this case, we know log and E will cancel out. Log and E will cancel out. So what will we get? Negative T divided by RC, which is equals to log 0.1. Till here clear? Okay guys, now just place the value. Okay, now place the value. So negative T equals to RC. What is the log 0.1? I'll write it here for you. Log bracket 0.1 equal, what is the value? Negative 2.30. Okay, so put it here, negative 2.30. So we get negative T equals to negative RC 2.30, and this negative cancel positive. So guys, from this equation also, do you understand something? T is directly proportional to RC, yes or no? T is directly proportional to RC, which I told you. Okay, and this is the positive value. So just place the values. T equals to, what is the value of R? Value of R is 50 multiply, what is the value of C? 100 multiply 10 raised to power negative 6 bracket multiply 2.30. So solve it. Time is equals to, what is the value? 0.0115 seconds. So if you write it, you can write like 11.5 times 10 raised to power negative 3 seconds. So 10 raised to power negative 3 means 11.5 millisecond. Clear? So this is the answer. Fine. We will solve it. Okay, there's a question number 1 for you. I told you, you need to remember only 2 things. One is the formula. Second, how to solve it. Fine. Okay. Draw on XYZ coordinate system and specify in terms of unit vector X cap, Y cap and Z cap the direction of the magnetic force. Okay. First thing, what is the formula? F is equals to Q V cross B. Okay, and here your force is also a vector. You have the 3 vectors I, J and K. Okay, we need to find the different things as per the question. So we are looking for magnetic force. Okay, case number 1. If you understand, it will become very easy for you. Very easy. Just you need to apply. First thing you need to check where the velocity is going up. Yes or no? There is a positive charge and magnetic field is going like this. Yes or no? Till here clear? Sure. Okay, in the question the graph is given. Graph is given. Okay, so as per this graph, can I say this is our positive Z cap? Fine. Okay, this is my positive Y cap. Fine. So what I need to find? I need to find the force. And which type of charge is positive? First understand this part. If you are able to understand, then you can solve all the cases. All the cases. F equals, charge is positive, positive. Fine. Charge is positive. I write positive. Bracket. Because we are looking for the direction only. Okay. So what is the V? Velocity. Because as per our formula, V should be the first one. So V is Z cap multiply Y cap. Okay, now just check the arrangement I, J, K. Yes or no? So what we are solving right now? K and J is the reverse. So it should be negative. It should be negative. So the result should be plus bracket. The result should be minus I cap. So what is the answer? The direction of force is negative I cap. Clear? Okay. So where is it is given? You see, this is the I cap. Here J cap. Here is K cap. So what should be the result? Negative I. It should be like this. Clear? Fine. So our result is minus I cap. Sure? Understand? Without using all the fingers, thumbs, no, it is very easy because in every question there are the limitations. You cannot solve it properly. Fine? Okay, now case B. Now try yourself, guys. Try yourself. I will write case number 2 here. Okay? Now just check this one. Where is the velocity? First check the charge. Which type of charge? Negative. Q is negative. Okay. Velocity is going upwards. Upward means positive Z. And your magnetic field. Now just check magnetic field B. Where it is going? It is going this side. And this is our Y cap. Fine. Okay, place the values. F is equals to, okay, F is equals to negative because of the charge. Then what we have, that is the velocity is Z cap multiply Y cap. Z multiply Y, what is the result? Tell me. Negative I. So the overall result is plus I cap. So where the body should go? Where should be the direction of force? This is the direction of force plus I cap. Clear? Okay. Third question, C part. See, I will use the other part also. Huh? C case number C. Okay, we will solve it here and I will just mark it C. Just think and solve, guys. First thing, you get the charge. Q is negative. Now it seems easy for you. Okay, you get the velocity. V is equals plus Y. Where is the magnetic field? Yes. Just check. It is going down. It means it is the negative Z. Magnetic field is going down. Yes or no? It is going down. So it will become negative Z cap. Okay, place them in the question. F is equals to negative bracket Y cap multiply negative Z cap. I told you how to solve. Y multiply Z. Okay, first negative, bring one more negative outside. What you have? Y multiply Z. Negative becomes positive. Negative and negative becomes positive. And Y multiply Z gives you I. So what is the result? I cap. So what should be the result? I cap. Clear? Okay. Now the fourth part, that is the interesting part. I will write D part here. Okay, what we have here, guys, just check. Okay, now what you need to see, you have the charge Q, which is equals to negative. Fine. Okay, velocity is going towards positive y-axis, and now the magnetic field. This is something which you need to focus, where the magnetic field is going. See, it shows us outside and inside. So this is O, this is dot. Dot means, if you remember, I told you dot means out. From the O, you can remember out. So here is the magnetic field which is going out. Out means positive x axis. Positive x axis. Clear, guys? Okay, I'll make it a little bit small. Now just solve the value of force. F is equals to negative bracket y multiply x. Y multiply x. So if you are multiplying y multiply x, then what should be the answer? Just tell me. Negative, they are reverse, y and x are reverse, so it should be negative k or negative z. So negative negative become positive z, and this is your result, positive z. So it is going like this. Clear? Okay. And guys, seriously speaking, if you understand this question, then you are able to solve lots of questions. Just review this video 2 times, 3 times. Basically, focus on the vectors part so that it will become easy for you to solve the questions. Okay. Now, guys, that is the real thing you need to understand. So just take out your calculators and we will start the questions. Okay. We have two equations and we know how to use them. I told you QVB sine of theta should be equals to mv square over r. Okay, remember this thing. Now we are going to solve and we are going to use three particles, okay, each of charge. So charge is given 6.15 microcoulomb. What does it mean? Solve the micro fast. 6.15, what is the meaning of micro? Multiply 10 raised to power negative 6. Clear? Coulomb. Speed is given, velocity is 465 meter per second. Okay, enters a uniform magnetic field with magnitude. Okay, B is given 0.165 Tesla. What is the magnitude of the magnetic force? Okay, we are looking for force. So force we know QVB sine of theta. Yes or no? Okay, in all the cases theta is given. Okay, change the color and change the strength also. Use it. Case 1. Case 1. F equals QVB sine of theta. Place the values. What is Q? 6.15 multiply 10 raised to power negative 6. Okay. What is the velocity? 465. What is the B? 0.165. What is the angle? Sine 30 degree. Guys, you just need to place all these values in your calculator and you will get 236 times 10 raised to power negative 4 Newton. Fine. Similarly, you can solve case 2. In case 2, your answer should be 4 force equals 4.72 times 10 raised to power negative 4 Newton. And in case 3, force should be equals to 2.36 times 10 raised to power negative 4 Newton. Okay, just you need to place the value of one time sine 30. In second case, it should be theta equals 90 degree. In third case, theta is equals to 150 degree. Fine. Okay. The major question, huh? So focus. Main problem, a rectangular loop. Okay, from the rectangle itself, rectangle. So we understand the first point. We have the word called area. And what is the area of rectangle? Length into width. Yes or no? Okay. Height is given. Height. Okay. H is equals to 6.5 centimeter. Okay, convert this 6.5 times 10 raised to power negative 2 meter. Width W is given 4.5 width here, huh? 4.5 centimeter, which is equals to 4.5 times 10 raised to power negative 2 meter. Okay, in a uniform magnetic field, B is given. B is 0.0 0.250 Tesla. Okay, no need to change. Which points in negative y direction. Okay, negative y cap. The loop makes an angle. Loops makes an angle of 33 degree with the y axis. Okay, with y axis. This is something very important, huh? With y axis, this is important. If something is with y axis, then what is the angle? Alpha with x axis. So in that case, alpha is equals to 90 plus theta. Then it will become 90 plus 33, which is equals to 123 degree. Understand? Whenever you need to focus on this statement, where the angle, because if the question will come and you see angle is 33 and you solve it, no, you need to check where it is given. Okay, shown in the figure, the loop carries a current is I is equals to 9 ampere in the direction of the arrow. Okay, what we are looking for? We are looking for the torque. We are looking for the torque, the rotational effect. Okay, now just solve it. We have everything. Torque is equals to I A B sine of theta or sine of alpha, you can say. So here, what is I? I is 9 multiply. What is area? You have height multiply width. I told you length multiply width. Length is in meter, width is in meter. So meter multiply meter, meter square. You need to check like this, units in the question. Sometimes they will give you with a different name. So don't get confused. Fine. 9 multiply 4.5 times 10 raised to power negative 2 multiply 6.5 multiply 10 raised to power negative 2. Okay, make it big. Okay, then area magnetic field 0.25 and sine 123 or 123 degree Celsius. Okay, 123 degree Celsius. Now just solve this. So once you solve this, we get torque is equals to 5.52 multiply 10 raised to power negative 3 Newton meter. Clear? Understand? Okay. You try to understand this question. 4 wires, each carrying a current of magnitude I. Okay, and guys, whenever you are solving the questions, you should know all the formulas. You learn some formulas. So one is dB is equals to mu naught over 4 pi I dl divided by r square. Yes or no? This is your first formula. Second formula, B is equals to mu naught I divided by 2 pi r. And third is where both the forces are there. Force is equals to mu naught over 2 pi r I1 I2 L. Okay, I1 I2 times of L. These are the formulas. You need to identify what we are looking for. 4 wires are each carrying current of magnitude I. Okay, I is given 1 ampere. The wires are located at the 4 corners of a square. Okay, so it means make another diagram, proper diagram, so that you can understand in a very good way. So here 1 2 3 4. Understand? Okay, so in that case we can understand this one also. This is our diagonal, we can say simply. Okay, let's say side is, okay, first we see, then we'll check the side. 4 corners of a square with side A. Side A is given. This is your side A, this is your side A, this is your side A, and this is your side A. If we solve the diagonal, okay, solve, let's say A, B, C, D. So if we want to find triangle A, D, C, okay, so we can solve AC is equals to A square plus A square. Yes or no? A square plus AC square is equals to A square plus A square. So this is your diagonal D square, or you can say 2 times of R square. 2 times of R square, or diagonal D square, or 2 times of R square is equals to 2A square. 4R square is equals to 2A square. R is equals to A divided by root 2. Clear? Yes or no? Sure. So this half distance is R, and this is equals to your A divided by root 2. Okay. Now we need to use this. Okay. Two wires are carrying current into the page. Okay. We have dot outside, cross inside, fine, and the other two are carrying current out of the page as shown in the figure. What is the y component of the magnetic field at the center of the square? Okay, very good. So guys, you need to solve it one by one. So if you solve one case, all cases are simple. Let's say this is the dot. Okay, this is your wire. It means current is outside. Out means plus Z. Yes or no? Out means plus Z. Okay, make a circle. Now your magnetic field should be in circular form. So if it is outside, just tell me what should be the direction. See, what you need to do, you just need to take your thumb. Okay, this is your thumb, and curl your fingers like this. Yes or no? Because it is going out of the page. So you can see what is the direction. The direction should be anti-clockwise. Direction should be anti-clockwise. So now the major thing what you need to see, you have to check, there are the two parts, left and right. This is your left part, this is your right part. Yes or no? So left part is going, you can see the directions are going upside. Yes or no? Okay, like this. Similarly, if you solve other wire, it will make like this, and the other two wires like this. I will redraw this in a proper form. So once you solve all the cases, you will get two wires will go like this, two wires will go like this, and we need to find the y component. So take the angle theta this side. Okay, make it big. I'll change the color so that it will be easy for you to understand. Let's say you find out first case, you understand it is going upside. Okay, let's make like this. Yes. Okay. So when you solve other three also, you will get angle theta. I'll change the color. So if this is your magnetic field B, so this will become your B cos theta. Okay. And this side will become B sine theta. Clear? So if it is in the middle, then theta equals to your 45 degree. Fine. So how many cases will be here? Just focus here. 1, 2, 3, 4. So every time, what will you get here? You will get total magnetic field is equals to B1 sine 45 degree plus B2 sine 45 degree plus B3 sine 45 degree plus B4 sine 45 degree. Yes or no? All are same. So can I say 4 times of B sine 45 degree? Yes or no? Can we solve this now? Okay, place the value. We know 4 times. What is B? What is the value of B? Just place it. Which formula? Formula number 2, because we are looking for the full wire. Okay, so mu naught over 2 pi. What is R? A by root 2. Okay, 2 pi mu naught I multiply sine 45 degree. Clear? Okay, I will add a page here so that it will be convenient for you to understand this one. Okay guys, now just continue this question. So we get 4 times of mu naught I divided by 2 pi a by root 2. Okay, sine 45 degree. Okay, solve it. We know sine 45 degree is 1 over root 2. Place all the values here. 4. What is the value of mu naught? Mu naught is equals to 4 pi times 10 raised to the power negative 7. So 4 pi times 10 raised to the power negative 7 multiply. Current is given 1. Divide by 2 pi. Okay, pi and pi is cancel. Okay, and now just place the values, all the values. Okay, 2 pi, and we have, okay, a by root 2. Solve this, and the value of a is, what is the value of a given here? A is 3.7 centimeter. 3.7 centimeter, which is equals to 3.7 times 10 raised to the power negative 2 meter. Okay, place it here. 4 times 4 multiply 10 raised to the power negative 7 divide by 2 multiply, what is the value? 3.7 times 10 raised to the power negative 2, and here your sine theta is 1 over root 2. So multiply 1 over root 2. Solve this. So you will get the value of total magnetic field, which is equals to 2.16 times 10 raised to the power negative 5 Tesla. Clear? Sure. Okay. The question number 1. What is the magnitude? What is the magnitude and direction of the magnetic field? Okay, we are looking for magnetic field, and we know the formula. B is equals to mu naught I over 2 pi r. Okay, so you have in this question, we have the value of I is equals to 3.4. okay, second thing, what we have, just check and tell me fast. So we have the value of distance d, which is equals to r, which is equals to 6.5. Yes or no? Okay, now just place this in the formula and let's see what you will get. Okay, so we know the value of mu naught, 4 pi multiply 10 raised to the power negative 7. Value of I is 3.4 divide by 2 pi. Okay, pi and pi is cancel, easy for you. And after that 6.5 centimeter. So convert this, we can say 6.5 times 10 raised to the power negative 2. So multiply 6.5 times 10 raised to the power negative 2. And once you solve this, you will get 3.8 multiply 10 raised to the power negative 7. This is the value. Okay, here we forget to write the values. And second thing, okay, we can check that one. So if the current is going up, just tell me fast, what should be the direction? Where we are checking? We are checking right side, and here is the left side. Okay, so if you curl your thumb, okay, this is your thumb and these are your fingers. Clear? So if you curl them, it is going up, so the direction is anti-clockwise. Yes or no? So if you check from here, it is going upside. It is going upside. Upside means out, outside the page or out of the page, you can say. So the answer is B. And guys, I just forget to write the values, but yes, if we have the different values, so you can just identify with the number and the direction is out of the page. Clear? Okay, now from these two graphs, you observe something, that this graph is keep on moving straight. Yes or no? So if you observe something at every point, they are equally distributed. Yes or no? Equally distributed. So can I say this graph should be the ohmic? Okay, here you can see it is not equal. You can just check here. Let's say this is at your position 1. 1 is something very high as compared to 2. It is not exactly 2. If you make it big, you can see at 2 it is 4. You can see the gap. Okay, at 3 you can see the gap is different. Okay, so they are not same. Clear? So this type of graph is called non-ohmic. Clear? Okay, let's move to the question number 1. What is the resistance type in group X? Okay, we already discussed about this thing, that is the non-ohmic. Okay, clear? Okay, now what is the resistance at volt 2? Okay, this is something good, we need to solve this. Okay, I told you something here. This one, ohmic, is easy to solve. Okay, let's say I'll change the color. 2 volt. This is your 2 volt, yes or no? And this is your I, that is the 4. Okay, first we solve the Y part, then we will solve the X part. Okay, we know as per the graph 1 over R, because here is current I, here is voltage V. 1 over R is equals to I over V. Okay, what is the I here? 4 divided by voltage is 2. So can I solve this? This will get 2. So 1 over R, which is equals to 2. Okay, flip this. R is equals to 1 over 2, which is equals to 0.5 ohm. Clear? This is the value of resistance. Okay, now solve for X. And I told you, whenever we have the non-ohmic, you cannot solve this directly. That, okay, you take a line and you solve it. No, not at all. You need to put a tangent on this and put a tangent like this. Do you understand? I'll make a straight line so that and change the color also. And you need to put a tangent over here. Clear? Sure? Okay, so this will give you the starting point is 2. So you need to check like this. This is your voltage and this is your current. So what is the current value? Now just focus. So for group X, so 1 over R should be equals to delta I over delta V. What is delta I? Final minus initial. 4 minus 2 divided by 2 minus 0. So 4 minus 2, 2 divided by 2, which is equals to 1. So R, you can say non-ohmic is equals to 1 ohm. Clear? And for ohmic, we have 0.5. So guys, this is the difference. Clear? Okay, now so the question is, there are the 1, 2, 3, okay. Calculate the resistance on R3. Calculate the resistance on R3. First, just see how the current is moving. Current is moving from here. Okay, let's change the color. Current is moving from here. Once it moves from here, R1 and R2, can I say R1 and R2, they are in parallel? Yes or no? Sure. If they are in parallel, I told you voltage V1 should be equals to V2 because both are in parallel, so it will remain the same. Sure. Okay, solve it. I'll put a line here so that we have more space to solve. Okay, so what should be the V1? It should be I1 R1. Yes or no? Sure. Okay guys, as per the numerical, I1 is given. What is I1? Okay, write out the value 0.5. And what is R1? The value is given 8 ohm. Put it here. V1 is equals to 0.5 times 8. So V1 is equals to 4 volt. Do you understand the first part? Sure. Okay. I told you V1 is equals to V2. This is your part 1. Now 2. As we know, V1 is equals to V2. Put the values. 4 equals to I2 R2. Yes or no? Okay. We don't know I2. What is R2? Just check. This is your R2, which is the 10. here is 4. So what is value of I2? 4 divided by 10, which is equals to 0.4 ampere. Fine? Clear? Okay. So let's come back to the question. We know the current, let's say current I is moving from here. So some part is moving here I1, some part is moving here I2. So can I say I is equals to I1 plus I2? Okay, so I1 is 0.5 plus 0.5, and what is the value of your I2? That is your 0.4. So can I say I is equals to 0.9? Sure. Is it clear? Okay. Now the current is going out from here and here, it will join again. So we will get I is equals to I1 plus I2. Fine. Okay. Now voltage at 3. This is something important. We need to find the R3 na. So we need to find V3, which is equals to I multiply R3. Yes or no? Okay. We understand V1 is equals to V2. This point we understand? Okay. Now you need to focus here. You have a battery of 15. And when you come here, V1 equals to V2. Both are of 4 volt. Yes or no? So this will be your potential drop. What is the meaning of potential drop? Means 4 volt is consumed in between R1 and R2. For R3, how much left and how to find out? So we need to find out V3 should be equals to VEMF minus V potential drop. Clear? So VEMF is 15 and drop is 4. So available voltage is 11. Yes or no? Clear? Available voltage is 11. So solve it. Use this formula and solve it. 11 equals. We know what is the I? 0.9. 0.9 times R3. Solve R3 equals 11 divide 0.9. Use your calculator fast. What is the value? 12.20. Clear, guys? Now you understand how the current is breaking, where you need to use the parallel rules, where you need to use the series rule, and the major concept where lots of students get troubled, the potential drop. Okay, potential drop. You need to focus in every question, because whenever the current is moving, there is a potential drop also. Clear? I'll give you the example so that you can clear. Let's say this is your car. You filled your car with the petrol. Okay, petrol is of you say 50 liter petrol. Okay, once you start moving, this is position A, this is position B. So at position A, your petrol is 47. So for B, if you are traveling from A to B, what is the value available? 47. And can I say 3 liter is your drop? Means you already utilize that one. That is your potential drop. So here 3 things. What is your voltage EMF here? You can say 50. Potential drop is your 3. And available voltage or terminal. So V is equals to VEMF minus V drop, which is equals to 50 minus 3, which is equals to 47. Is it clear now? Okay. Now, let's move to the question first. That is your main question. You need to focus. In the circuit shown in the figure, V1. Okay, we have the V1 here. V1, the value is 1.5 volt. Okay, I'll make it a bit smaller. Okay, now V2 is 2.5 volt. Fine. Okay, R1, okay, it is given 4 ohm. R2 is given 5 ohm, 5 ohm. Okay, what is the magnitude of I1 flowing through the resistor R1? Okay, whenever these types of questions will come, let's say in this question, it is very good, A, B, C is given. So there is a step 1. Step 1, give the names. Name them, name them. A, B, C, so on. Clear? Step number 2, prepare the loops. Prepare loops. Okay, let's say in this question we are looking for I1. Okay, where is I1? Is it given here? Just tell me, is it given there? Okay, no. So can I say it will move like how it will move? This is V1. So from here, the current which will flow, that is your I1. So shall I take a loop? I'm taking a loop, huh? A, B, E, this one, E, F, A. Okay, take this loop. Okay, then I'm going to start with, see, this question I'm explaining you in too much detail, huh? So that other question will become easier for you. Okay, take this loop like this. I'll make it again for you so that it will become easier for you. First part, there is a voltage. Okay, in terms of voltage, just try to understand. This is your V1, this is your positive, this is your negative. From where you are starting your, so you are starting from here. The current is going from here, I1. It means V1 is positive nature. Yes or no? So can I say V1? Okay. Now you have a resistance here. What is my loop? A, B, E, F. So this is my loop, yes or no? Okay. So this resistance is under my loop. So can I say here should be V, whatever the value of voltage. So it should be minus I1 R1 because there is resistance is R1. Yes or no? So can I say minus I1 R1? Clear? Okay. After that, I have a loop. I have a voltage here. This voltage you need to compare, huh? This voltage 2.5. Just check what is the direction. So it is entering in negative and exit out from positive. Yes or no? Okay. So just check V2. V2 should be positive V2. Clear? So positive V2. Okay, now your circuit is closed. So equals to 0. Equals to 0. Clear? Fine. You understand this structure and you understand why positive, why negative. Now just place the values and find out. So we are looking for V1 is 1.5 minus I1 we are looking for. R1 is 4 plus V2 is 2.5 equals to 0. Okay. So take this value this side. So 1.5 plus 2.5. When you take it that side, it will become positive I1 multiply 4. So 4 equals to 4 I1. I1 is equals to 1 ampere. Clear? You understand? See, if you give them the names and you are preparing the loops accordingly and give them the signs, question is finished. Nothing much more. Okay? Which I forget, huh? Okay, now solve this one. Okay, as we have the formula, what is the formula? QVB sine of theta is equals to mv square over r. Depending upon the situation, we can use them. Okay, what is your main question, huh? Focus here. A laboratory electromagnet produce a magnetic field. Okay, magnetic field is given. So magnetic field B is 1.5 Tesla. Okay, a proton, remember this thing, huh? Proton, whenever they will give you proton or electron, proton, there are two things you should remember. One is called charge 1.6 times 10 raised to power negative 19 coulomb. Okay, and the mass of proton is 1.67 times 10 raised to power negative 27 kg. Remember this thing. Whenever they will give you electron, charge Q is 1.6 times 10 raised to power negative 19 and mass of electron 9.31 10 raised to power negative 31 kg. And you can check these values can be given in your formula booklet also. Okay, so no need to worry, just remember all these things. Move through this field with a speed. Okay, so velocity is 6 multiplied 10 raised to power 6 meter per second. Okay, three factors are given: 1, 2, okay, 3 and 4. Four factors are given. Okay, what we are looking for: magnetic force. What is the formula of force? F is equals to QVB sine of theta. If angle is not given, no need to use that. So Q, what is Q? 1.6 times 10 raised to power negative 19. V, velocity is 6 multiplied 10 raised to power 6. B is 1.5. And if theta is not given, leave it. So what is the value? Solve it fast, fast, fast. Okay, the answer is 14.4 multiplied 10 raised to power negative 13 Newton. Clear? Okay, now move to the next part. What is the magnitude of maximum acceleration? Do you remember? We learned about the Newton's second law, F equals ma. Yes or no? So we are looking for a, F divided by m. Okay, force we already have and mass we already know. Okay, place them. A is equals to 14.4 times 10 raised to power negative 13 divided by. Okay, mass is 1.67 times 10 raised to power negative 27. Solve the acceleration fast, fast, fast. 8.62 times 10 raised to power, yes, solve it, solve it, solve it. Here is negative 13, huh? Negative 13, yes. Okay, your value is 10 raised to power plus 14 meter per second square. Fine. Okay. Now the C part. The proton is now replaced with electron. Okay, now we have to use the electron. And I told you the mass. Okay, we have both the things, charge and mass. Remember, charge of electron is charge of proton. Mass of electron is very less than mass of proton. Yes? Okay. So what we need to find? Would the field exert the same magnetic force? Okay. So F is equals to QVB sine of theta. So Q is same because charge is same. So force equals to same. Clear? Okay. Would the electron experience same acceleration? F is equals to ma. A is equals to F by m. Okay. Now in terms of electron, mass is less. So the acceleration is more. Do you understand? Less mass, more acceleration. Clear? Sure? Okay. So now, sure? Okay, now let's move to the question number 1. That is your main problem. As per your EOT, a loudspeaker produces sound by exerting a magnetic force on the voice coil. Coil means wire, a circular wire in a magnetic field. The magnitude means the value of the magnetic field is, okay, the given value. So given is your first thing is magnetic field. B is equals to 1.5 Tesla. The voice coil is composed of N. Okay, we have the N number of turns. 100 turns, or you can say 100. Let's say I'll tell you something. There is a one wire and This is the wire, and on this you have lots of n number of turns. Clear? Okay. Current I is equals to 1 milliampere. Milli means 1 multiplied 10 raised to power negative 3 ampere. Milli means 10 power negative 3. Diameter, okay, D is equals to 2.5 centimeter. Okay, convert this 2.5 centi into meter multiplied 10 raised to power negative 2 meter. Okay, what is the magnetic force? Okay guys, we need to solve force exerted by magnetic field on the loudspeaker coil. Okay, solve it. What we have, F is equals to ILB sine of theta. Theta is not given, so no need to use it or take it 90 degree. So I is given. Okay, so in this what you need to focus, N also given, number of turns. So it should be N times ILB. Okay, so N is 100. Current is current 1 multiplied 10 raised to power negative 3. L. Now you need to solve. I told you L is equals to pi D. I told you earlier. So pi times D is given, multiply 2.5 times 10 raised to power negative 2. Okay. And B 1.5. Okay. Put in a bracket 1.5. Yes or no? Clear? All these things, and you need to use pi as 3.14 so that it will become easier for you to solve them. Put all these value in your calculator, so force will be 0.0118 Newton. Clear? Logic is clear, na? So if the logic is clear, you are able to solve it. Fine? Okay.